talk. We are going to move along now to the final project talk of this year's event, which is from Anna Liljedahl of the PERMAFROST Data Gateway. And Anna pre-recorded her talk, so if events could get that started now. Thank you.
Hi, and welcome everyone. Good to have you here. My name is Anna Liljedahl. I am in Homer, Alaska, and I will be presenting to you about the Permafrost Discovery Gateway. And I am very fortunate to have a stellar team that I very much enjoy working with. So the Permafrost Discovery Gateway is there to take the pulse on the Arctic, which is changing rapidly due to permafrost thaw. And it's a remote region, a big, large area. And the only way to, I think, really keep track on the rapidly changing landscape is to utilize satellite imagery and combine it with big computers so we can really track the changes as they are occurring. So the Permafrost Discovery Gateway is there to both create and enable the discovery of big geospatial permafrost data. And here is the mock-up of how the Permafrost Discovery Gateway might look like through various visualization tools. So an overview of the Permafrost Discovery Gateway Clowder instance here. So our mission is to automate and optimize geospatial big data creation from the satellite imagery. And Clowder and its extractor and geoserver, which are deployed, are using Helm charts. And these extractors take advantage of the file system using persistent volume claims due to large file size. And we currently have two codes that are deployed on Clowder, and that is Maple and Landsat trend that I'll show you next. So one of our missions is to map ice wedge polygons across the Arctic tundra. And you can see them here. They're about 30 meters or so across, and they are indicator of ice-rich permafrost. So which is very challenging if you have melting ground ice in a warming climate, especially for infrastructure. And here, Shani Vitarana, Rahida Udavapola have developed Maple, mapping application for Arctic permafrost land environment. So they take optical high-resolution imagery from the Polar Geospatial Center and then map individual ice wedge polygons. So each of them get a number devoted to them. And currently, Shandi and Rahida have mapped the areas here shown in red, and the green ones are in progress, and then the gray shaded areas are regions that they will map here in the next couple of months. And we have multiple publications already out on this. So the extractor related to Maple in Clowder uses GeoSTIFF satellite images as input data. And the classification of ice wedge polygons are done using deep learning convolutional neural network techniques. And then the output is in a shapefile. So these boundaries of ice wedge polygons. And in this process, Todd has also added a geoserver geoserver tool in here. So Shandi and Rahida can look at their results and see how the code is doing before deciding if they want to retrain the code or such. And to the right is also an example of how the Maple extractor looks like in Clowder, as how the user is interfacing with it. And there's multiple strategies, or two main strategies, to connect Clowder to exceed resources in order to map these ice wedge polygons through Maple. So strategy one is to start with input or raw files on the Permafrost Discovery Clowder instance, and then submit these to exceed using a Python Parameco VFX package for these SSH and SCP, and then submit at dataset level, and finally upload the products and metadata using PyClowder calls from Exceed. The second strategy is to start with input and raw files on Exceed or another high performance computing resource, and then upload the original and the products using PyClowder into a predetermined hierarchy of spaces and collections of data sets. So the reasons for these two strategies are to get faster computing and also to access GPU resources which are not available on Radiant currently. So the other code is Landsat Trend, and that uses Landsat imagery and the classification here of lakes and fire scars and thaw slumps are done using a random forest model training. Here, the inputs is also GeoTIFF, and the outputs are shapefiles that you can see here on the right. And both Maple and Landsat Trend extractors use persistent volume claims so that large files are stored on the file system and not in the container. And yeah, you see how you execute the window where you execute Landsat Trend on the right there. And on the lower left is also a photo of a thaw slump that is being mapped across the Arctic with this tool. So I mentioned DS Server before, and that is a layer preview for extractor results. So sort of a plotting tool for the user to check the results before deciding if the product is indeed final or if they want to fine tune the code further. And another example of how we're integrating Clowder into the Permafrost Discovery Gateway is to make big data into small data. So NASA has a huge public data archive with gigabytes of imagery coming in every day, atmospheric data. And we wanted to make this data a bit smaller so it's a little easier to work with, especially people who might be on limited bandwidth on their internet. So here, Galina Bin and Luigi Marini are combining Clowder and Docker and to create smaller data files from the NASA public archives. And finally, the data being developed through Clowder, through the pipeline and the workflows in Clowder is then being exported into the Arctic Data Center, where we have the main visualization tools housed. And here's an example of the current look of the imagery viewer, which is aimed to allow the user to zoom in and look at individual ice wedge polygons and at the same time zoom out across the Arctic and see where the ice wedge polygons are across the Arctic. And that will be populated with other data sets such as surface water, also mapped from this very high resolution optical imagery and the Landsat Trend data and so on. And the other visualization tool in the Permafrost Discovery Gateway is the Fluid Earth Viewer, which is optimized for rapid loading and smooth interaction with global scale raster data sets. So this is a much coarser resolution of the spatial data. And you can see wind and current streamlines moving, and it's a user-controlled, smooth controlling animation across time as well, kind of fun. And it can be run as a standalone version or as a simplified component for use in other apps, such as the Permafrost Discovery Gateway. So here, we're taking Permafrost map products developed through Clowder and making them into secondary, a bit coarser products that we can show in Fluid Earth Viewer. So I'll leave it at that. And we are almost halfway into our project, and it's a 4-year project. And we're funded by the Navigating New Arctic. And yeah, thank you very much. Check out our website and please contact me if you have any questions or thoughts. Thank you very much.
Thank you so much, Anna, for your presentation. Really exciting to see the progress that you've made so far and where you're going from here.
Yeah, I might just add that we have our first sort of release of the Permafrost Discovery Gateway will be in late October, because we have a big Permafrost conference coming up there, and that's the Permafrost science community that we're really targeting. And so there we will actually have interactive versions of the imagery viewer that I show there, and Luigi, and Todd, and Kenton will present on the workflows that they developed together with Kenton, together with Shanti and Ingmar on the Maple and Landsat Trend.
That's great. Thanks. Yeah. Is there any links or anything else related to this that you want to share that we can make available to the group? We'd be more than happy to do so. So thank you. Cool. I'm curious. My own question is, are you literally dialing in from the field there? I'm just admiring your setup.
I know. Yeah, I'm sitting in my Pentagon headquarters. I bought land beyond the end of the road, so I have 2 miles on ATV with tracks of a wetland, and then I have high-speed off-grid living situation with internet, and it's a mile to my nearest neighbor, and I love it here. It's a gorgeous view.
Oh, wow, that sounds magical. Yeah. Well, thank you for joining us remotely, as probably the most remotely of anyone who is presenting here. And thank you again for that very insightful talk.
Thank you.